Here's how simple this actually is. The short version. When you see a base and then you see a log of the same base, whether it's the base raised to the log of the same base, or you see log first and you have log base b of the same base, the double b's. So double b's or double b's. Every time your answer drops down, it just becomes the x. So when you see 10 log base 10 of 4, the answer is 4. The shortcut is people say they just cancel out. That's not actually true. The truth, and here's why, is because you have, in this case, bia, and all you gotta do is convert to bay. If you convert to bay, we have log, the base is 10, the answer is a box, and the exponent is log base 10 of 4. What has to go in the box? 4. When you see E and ln, because of what we just talked about up here, the same thing is happening. If we were to have proved those as inverses, they also would have given us x. So you can say it cancels and the 9 just drops down. Sure, you can do that. That is a shortcut. That is something that's easy for you to catch on to if you memorize the pattern. But I don't want you to know just the tricks. I want you to know the why. So here's the why. E to the ln, remember ln is log base e. You have another bia. Base exponent, that equals an answer. So if you convert this to bay, and log is bay, you have a base of e, as in Euler's number 2.71828. You have an answer, and in the answer spot is an empty box at the moment, and that equals an exponent. The exponent is the natural log of 9. Natural log is log base e. So if log base e of box equals log base e of 9, what does the box have to be? It has to be 9. Yes, shortcut, they cancel, drop it down, but there's actual math happening here. Which brings me to the last one. They don't match, but I clearly am leading you somewhere. You have to get a little creative, but it's all in your bag of tricks that you have been cultivating over this entire year, and you've done very, very well learning a lot of hard math. So check this out. Instead of 27, what if I wrote 3 cubed instead? Isn't 3 cubed 27? 3 times 3 is 9 times 3 is 27. So 27 to the x is really 3 to the 3x. Keep in mind, if 27 is 3 cubed and you have an x that's being raised, you have a power to a power. You multiply the powers. That is super messy, I apologize. 3 to the third is 27, and that's being raised to the x. Power to a power, you multiply the powers. So, what has to be the answer? What goes in the box? Hopefully you've caught on. If you're doing the shortcut, you'll see that those are a match, which means that drops down. If you actually want to know the why, which I always appreciate, understand that this time you are starting off with the word logarithm. So you are being given bay. Let's convert to bia and see what happens. The base is 3. The exponent is empty box. And the answer is 3 to the 3x. 3 to the box equals 3 to the 3x. Do you see why? The box has to be 3x for that to make sense. Okay. You're doing great. And we're almost done. Last part. To refresh finding inverses of functions. Remember that it was more than just switch x and y. When I taught you how to find an inverse in Unit 2, you had to not only switch x and y, you had to go solve for y. Well, when you do that in logarithm and exponential forms, there's a middle step. So let's start with the basics. If I switch x and y to find the inverse, this is great, but it's not solved. You have to solve for y. So the question is, how do I go from here to here? Because that's going to be the end goal, is getting y equals. Well, just switch the format. Notice that you have 8 to the y equals x, and if you don't see the word log, it must be exponential, it must be bia. And since log is bay, just switch it. So log base, the base is 8. Answer, the answer is x. And that equals the exponent. The exponent is y. So y equals log base 8 of x. Now, the shortcut for this, it was right there. But this went from an exponent to an answer, again, because you switched x and y. Okay? Let's try another bia. So the base is e, the exponent is x plus 2, and the answer is y. Except step 1, my bad. Switch x and y. Okay, let's try that again. The base is still e. The exponent is y plus 2. The answer is x. So we're going to now write it in the opposite form. And the opposite form of bia is bay. Log is bay. The base, e. The answer, x. The exponent, y plus 2. Remember that log base e is ln, natural log. And you're almost finished. You just need to subtract 2. So then our final answer is y equals natural log of x minus 2. That is a shift down because it's not in a parentheses. It's happening outside of the x. That is not right. That is down. Okay, last 2. Remember, natural log is log base e. This is a shift left. This is a shift down. That's inside with the x. Step 1, switch x and y. X equals log base e, in parentheses, y plus 3. That parentheses has to stay there. It's still pertaining to that plus 3. Inside now with the y. Step 2, write in opposite form. You're given a logarithm. So log is bay. We're going to switch to bia. The base, e. The exponent is x. And the answer, that whole quantity y plus 3. So then to get y by itself, you're going to subtract 3. That is on the outside. That is a shift down. It's not in the x or the parentheses. All right, last one. This one's a little bit weird, just a little bit. So you have logarithmic form, but I want you to notice how you don't have log leading the way, and you want it to lead the way. You do not want the -4 there. So we're going to divide by that -4. So we have negative 1/4 y, or you could put y over negative 4, it doesn't really matter, equals log of x. I want you to remember that whenever you don't see the base, it's called the common logarithm, and the common log is base 10. So there's a cute little invisible 10 you have to know is actually there. All right, now that we've solved and we've gotten log by itself, switch x and y. So we have negative 1/4 x equals log base 10 of y. Notice that log is base answer, and that equals an exponent. Write in opposite form, which is BIA. So our base is 10. Our exponent is negative 1/4 x. And our answer is y. So y equals 10 to the negative 1/4 x, or you could put negative x over 4. It doesn't actually matter. Okay, you survived. Good job, and I'll see you on the next one.